We're living through a revolution. Just a few years ago, writing code meant spending hours debugging, searching through documentation, and wrestling with syntax errors. Today, AI-powered coding assistants have transformed that entire experience. What once took hours can now be solved in seconds. A developer can describe what they want in plain English, and watch as AI generates working code, suggests optimizations, and even helps architect entire systems. This isn't just a tool, it's a fundamental shift in how developers work. Code generation, optimization, debugging, and even architectural decisions are being augmented by artificial intelligence. GitHub Copilot, ChatGPT, Claude, and countless other AI assistants have become as essential to modern development as the keyboard itself. The numbers tell the story. Millions of developers are using AI coding assistants daily. Code completion rates have skyrocketed. Time spent on repetitive tasks has plummeted. But here's what's really interesting: not all languages benefit equally from this AI revolution. But here's the question that's been nagging at the back of every developer's mind: when AI can generate code in any language, does your choice of programming language still matter? And if it does, which language can better utilize AI effectively? The answer isn't what you might expect. On the surface, it seems like language choice shouldn't matter. After all, if AI can write Python, JavaScript, or Rust equally well, why not just pick the one you're most comfortable with? But dig deeper, and you'll discover that some languages create a better partnership with AI than others. Think about it this way: when you're working with AI, you're not just getting code generation. You're getting a collaborative partner that learns from feedback, adapts to your style, and improves over time. The question becomes, which language provides the best feedback loop? Which language helps AI become a better partner? Python dominates AI-assisted coding, and for good reason. Its simple syntax makes it incredibly easy for AI models to generate correct code. The extensive documentation, massive community, and rich ecosystem mean AI assistants have more training data and context to work with. When you ask an AI to write Python code, it's drawing from millions of examples. Stack Overflow answers, GitHub repositories, documentation, the training data is vast. But Python has a weakness when it comes to AI assistants: it's forgiving. Too forgiving. An AI can generate Python code that looks correct, passes basic tests, but contains subtle bugs that only surface in production. Type errors, non-reference errors, unexpected behavior, these slip through because Python doesn't catch them at compile time. JavaScript and TypeScript excel in web development. Modern AI coding tools are exceptional at generating React components, API endpoints, and full-stack applications. The type safety of TypeScript helps AI catch errors before they happen, creating a feedback loop that improves code quality. But even TypeScript has its limits. It's optional typing, which means the AI can still generate code that bypasses type checking. The real challenge with AI-assisted development isn't generating code, it's generating correct code. And that's where the choice of language becomes critical. But there's a language that creates something even more powerful, a true partnership between developer, AI, and compiler. That language is Rust. Rust emerges as the optimal programming language for AI-assisted development. Its unique combination of features creates a perfect partnership between developer, AI, and compiler. Let's explore what makes Rust the best choice. Let's start with Rust's type system. It's a game changer for AI-generated code. When an AI model writes Rust code, the compiler immediately validates it. Type inference and explicit types provide clear context for AI models, helping them generate more correct code from the start. But more importantly, the compiler catches errors that AI might miss, creating a safety net that makes AI assistants more reliable. Here's what makes this special: Rust's type system isn't just strict, it's helpful. When the compiler finds an error, it doesn't just say wrong type. It explains what went wrong, suggests how to fix it, and provides context that helps both you and the AI understand the problem. Imagine asking an AI to write a function that processes user data. In Python, the AI might generate code that looks correct but fails at runtime with a type error. You run the code, it crashes, you debug, you fix it. In Rust, the compiler catches that error immediately. The AI gets instant feedback, learns from it, and generates better code on the next attempt. This isn't just about catching bugs, it's about creating a learning loop that makes AI assistants more effective over time. The type system does more than catch errors, it guides the AI toward better designs. When you're working with Rust, the AI is forced to think about types from the beginning. It can't just throw together some code and hope it works. It has to design with types in mind, which leads to more thoughtful, more maintainable code. But it's Rust's ownership system that truly sets it apart. The borrow checker prevents entire classes of bugs that AI might introduce: memory leaks, data races, use after free errors. These are vulnerabilities that could slip through in other languages, but Rust's compiler acts as an additional layer of validation for AI-generated code. Consider this scenario: you ask an AI to write a concurrent data processing system. In C or C++, the AI might generate code that compiles but contains subtle memory safety issues that only surface under specific conditions. Maybe it's a race condition that only happens under load. Maybe it's a use after free that only triggers with certain inputs. These bugs are nightmares to debug, and they're exactly the kind of thing AI might introduce when generating code quickly. In Rust, the compiler won't let that code compile. The AI is forced to think about ownership, lifetimes, and safe concurrency patterns. The result? More correct code, fewer vulnerabilities, and a system you can actually trust. The borrow checker isn't just preventing bugs, it's teaching the AI about safe programming patterns. This is especially crucial in the age of AI-assisted development. When code is generated quickly, there's a temptation to skip thorough testing. After all, if the AI wrote it, it must be good, right? Wrong. AI-generated code needs validation just like human-written code. Rust's compile time guarantees reduce the need for extensive runtime testing, making the AI development cycle faster and more reliable. You're not just getting code that works, you're getting code that's provably safe. Performance matters too. Rust's zero-cost abstractions mean AI can generate high-performance code without sacrificing safety. You get the speed of C++ with the safety guarantees that make AI-assisted development trustworthy. When an AI generates Rust code, it's not just creating something that works, it's creating something that works fast, safely, and efficiently. This is important because AI-assisted development often means generating a lot of code quickly. In languages where performance requires careful optimization, the AI might generate code that works but is slow. In Rust, the AI can use high-level abstractions without worrying about performance penalties. The compiler handles the optimization. But perhaps most importantly, Rust's compiler becomes your AI's partner. It provides immediate, detailed feedback that helps AI learn and improve. Those famously helpful error messages. They're not just for humans, they guide AI models toward better solutions. When the compiler says expected type X, found type Y, consider using Z, the AI can use that information to generate better code on the next attempt. This creates a unique development experience. You're not just using AI to write code, you're using AI, guided by a compiler that's actively helping both you and the AI understand what's wrong and how to fix it. It's a three-way collaboration: you describe what you want, the AI generates code, and the compiler ensures it's correct. The feedback loop is immediate and actionable. The AI doesn't have to wait for runtime to discover errors. It doesn't have to guess what went wrong. The compiler tells it exactly what's wrong and often suggests how to fix it. This makes AI assistants more reliable, more efficient, and more effective. The benefits extend beyond individual projects. Rust's focus on safety and performance aligns perfectly with modern software development needs. As more critical systems adopt Rust, from operating systems to web browsers to blockchain infrastructure, AI tools are getting better at working with it. The community is growing, The ecosystem is expanding, and the language is evolving in ways that make AI assistants even more powerful. Major tech companies are investing in Rust. Microsoft is using it in Windows. Google is using it in Android. Meta is using it in critical infrastructure. As these companies build more Rust code, AI models have more examples to learn from. The training data is improving, and so is the quality of AI-generated Rust code. This isn't just about today, it's about building software that will stand the test of time. When you combine Rust's safety guarantees with AI's ability to generate code quickly, you're creating systems that are both fast to develop and reliable to deploy. You're getting the best of both worlds, the speed of AI-assisted development with the confidence of compile-time safety. The AI wave is here. The question isn't whether to use AI, it's how to use it most effectively. And when it comes to maximizing the benefits of AI in your coding workflow, Rust isn't just a good choice. It's the best choice. The compiler becomes your AI's teacher, the type system becomes your safety net, and the ownership model becomes your guarantee that the code you ship is as safe as it is fast. Consider the alternative, using AI with a language that doesn't provide these guarantees. You get code faster, yes. But you also get bugs faster. You get vulnerabilities faster. You get technical debt faster. With Rust, you get all the speed of AI-assisted development, but you also get confidence. Confidence that the code is safe. Confidence that it's performant. Confidence that it will work as expected. This isn't theoretical. Developers using Rust with AI assistants report fewer bugs, faster iteration cycles, and more reliable deployments. The compiler catches issues that would otherwise slip through, and the AI learns from those corrections, becoming more effective over time. In a world where AI can write code in any language, the language that helps AI write better code is the one that will define the future of software development. That language is Rust. It's not just about what AI can do for Rust, it's about what Rust can do for AI. And together, they're creating a new paradigm for software development, fast, safe, and intelligent. The future of coding isn't about choosing between AI and traditional development. It's about choosing the right tools that work together. And when it comes to AI-assisted coding, Rust isn't just a language, it's a force multiplier. It makes AI better, and AI makes Rust more accessible. That's a partnership worth investing in.